Next problem. If f of z is equal to z f of n, find f of 0 and f of 1, where capital F of z, which is equal to z by z minus 1 plus z by z square plus 1. Given capital F of z, which is equal to z by z minus 1 plus z by z square plus 1, right? By initial value theorem, we know f of 0, which is equal to limit z tends to infinite f of z, right? So replacing f of z by z minus 1 plus z by z square plus 1, right, is equal to limit z tends to infinite z by taking that z outside, so you will get 1, right, minus 1 by z, because when you are removing that z, so first term 1 into z, second term z into 1 by z, then you will get 1, right? So z into 1 minus 1 by z plus z by the second term taking z outside, so you will get z into remaining, you are having z, right, z into z square, then z by z 1, so z plus 1 by z. So limit z tends to infinite, so you can cancel z, numerator z and denominator z, you will get 1 by 1 minus z. Similarly in the second term, numerator z and denominator z get cancelled, so you will get 1 by z plus 1 by z, right? And when limit z tends to infinite, so 1 by 1 minus 1 by infinite 0, so you will get 1 by 1 minus 0, so 1 by 1, so you will get 1 first term. Similarly in the second term, 1 by, as z tends to infinite, so infinite plus 1 by infinite, 1 by infinite plus 0, so 1 by infinite 0, right? So second term 0, therefore f of 0 equal to 1, right? Next we need to find f of 1. We know f of 1, which is equal to limit z tends to infinite z into z by z minus 1 plus z by z square plus 1 minus f of 0, right? That is equal to limit z tends to infinite, because f of 1 is equal to limit z tends to infinite z into capital F of z minus f of 0. That is the formula, right? It is that f of 1, which is equal to limit z tends to infinite z into capital F of z minus f of 0. So we replaced capital F of z by z minus 1 plus z by z square plus 1. That is why f of 1 is equal to limit z tends to infinite z into z by z minus 1 plus z by z square plus 1 minus f of 0. Replace the value. F of 0 we know 1, right? That is why we is equal to limit z tends to infinite z into z by z minus 1 plus z by z square plus 1 minus 1. So limit z tends to infinite z into z by z minus 1 minus 1, right, plus z by z square plus 1. So taking LCM, we are grouping z by z minus 1 minus 1, right, together. Limit z tends to infinite z into, so cross multiplying z minus z plus 1, right, minus 1 into z minus 1 minus z minus 1 into minus 1 plus 1 divided by z minus 1. So z get cancel, so you will get limit z tends to infinite z into 1 by z minus 1 plus z by z square plus 1, which is equal to limit z tends to infinite z by z minus 1. We are multiplying that z inside, right, and z square by z square plus 1. So that is limit z tends to infinite, taking z outside in the denominator, so you will get z by z into 1 minus 1 by z. And similarly, you take z square outside in the denominator, right, plus z square by z square into 1 plus 1 by z square. So z get cancel, z square also get cancelled. You will get limit z tends to infinite 1 by 1 minus 1 by z plus 1 by 1 plus 1 by z square. Taking limit, you will get 1 by 1 minus 1 by infinite, as z tends to infinite, 1 by infinite 0. So 1 by 1 minus 0, you will get 1 first term. Similarly, the second term 1 by 1 plus 1 by infinite, 1 by infinite again 0. So you will get 1 by 1 plus 0. So you will get 1 by 1, 1 second term. So 1 plus 1, that is equal to 2. Therefore f of 1 equal to 2. Next problem. Verify initial value theorem for f of n, which is equal to 2 power n plus 1 by n factorial. So by initial value theorem, we know f of 0 equal to limit z tends to infinite f of z. So given f of n, which is equal to 2 power n plus 1 by n factorial. So f of 0, replace n by 0, you will get 2 power 0 plus 1 by 0 factorial. 2 power 0 plus 1, 2 power 1. So numerator, you are having 2. Denominator, you are having 0 factorial. 0 factorial 1. 2 by 1, 2. That is equation number 1. Now f of z is equal to z transformation of f of n is equal to z transformation of 2 power n plus 1 by n factorial. That is equal to z transformation of separating the powers. So 2 into 2 power n by n factorial. That is equal to 2 into z of 2 power n by n factorial. Taking that 2 outside. That is equal to 2 into z of 2 power n by n factorial. Formula e power 2 by z. Because z of a power n by n factorial is equal to e power n by z. So a power n by n factorial is nothing but e power a by z. So instead of a, you are having 2, right? That is right. So 2 into e power 2 by z. So limit z tends to infinite capital F of z, which is equal to limit z tends to infinite 2 into e power 2 by z. As z tends to infinite, 2 by infinite become 0, right? 2 by infinite 0. So e power 0. 2 into e power 0. E power 0 equal to 1. So 2 into 1, you will get 2. Tends to infinite f of z, which is equal to 2. That is equation number 2. So from 1 and 2, we will get f of 0, which is equal to, because right hand side equal 2, 2. First equation, right hand side 2. Second equation, right hand side 2. Therefore left hand side equal. So f of 0 is equal to limit z tends to infinite f of z, that is equal to 2. So we have verified the initial value theorem, right? F of 0 equal to limit z tends to infinite f of z, right? Thanks. We'll see in